Yep. You're good.
Okay, so 2.3, away we go. Similar somewhat to yesterday, because we're graphing a thing called sinusoids, which is sine and cosine graphs. What is the main difference when you look on the board today compared to what we looked at yesterday on the board and in our homework page?
It's got a plus in it.
It's got a plus sign. Yesterday, all the numbers were always doing what? Multiplying. So if we were multiplying in the beginning as a recap, what word was that? If I do this, what, the 2 is the amplitude. What did that do to our graph? Made it taller. If I went and multiplied in here, that caused the word called
Period.
period. How did we figure out the period?
360 divided by that.
360 divided by that number. And what that did is made the graph get probably smaller, but possibly wider. Depend on what what number did you divide by? What kind of number did we divide by at some point that made it wider?
Like decimals.
Decimals or fractions, yeah. Today that goes out the window. Today we're not multiplying. Today we're adding and subtracting. So we could rely on our algebra experiences maybe. In our algebra experiences, multiplying always made it wider or taller. Does anybody remember what adding and subtracting used to do in those experiences?
Left and right.
Moved it left or right sometimes.
Up or down?
Could also move it up and down sometimes. It depends on where we put the number. Does anybody have a theory on what this might do for our graph?
Well, right.
He guesses right too. Let's graph it and see. So let's go calculators. Do y1 as sine. Do y2 as 2 plus sine. And we'll see. Did it go right too?
What are we entering?
Up to.
So y1 is just sine x. y2 is 2 plus sine x. Our guess that we had on hand was that was going to head us right to. Then the machine says
Up to.
up to. If there's a number adding out in the front, that is a thing that we're going to call the vertical displacement. This graph has a vertical displacement of 2. Just let me take a step to the right. Would this have a vertical displacement? No. Just let me take another step to the right. Would this have a vertical displacement?
Yeah.
What would the vertical displacement be for this?
3. Negative 3.
Negative 3, I agree. Stepping into cosine town. Does this have a vertical displacement?
Yes.
Yes. Of,
Negative 4.
does this one?
No.
Does this one?
Yes.
Vertical displacement
2.
2. Rolling back to the left. Which of these letters is giving us a vertical displacement?
C.
The C. This is giving us a thing called the vertical displacement. That just means it's moving it up or down. Question about that? Let's look at the one to its right. Anybody have a thought on what that is going to do to us?
The minus 21.
Mm-hmm.
Or right 20.
So he's guessing right 20. Anybody else care to guess?
I'll say left 20 just to
Say
give a
left
different.
20. We'll try it out. We'll see what happens.
What we're putting in is sine x minus 20.
Yeah, so y1 is just sine x. y2 would be sine parentheses x minus 20.
And if it went right 20 degrees.
It did go right 20 degrees. This number is going to be a thing called the phase displacement. And you may remember from Algebra 2 experiences, if you still remember things that happened during the quarantine, that when there were numbers inside the parentheses, it always had an opposite effect from what you expected. The minus 20 does feel like it should go either left or down. Like this did. This negative 3 is going to go down. but in the parentheses, it's always like an opposite field. The minus 20 would actually head us right 20. This has a phase displacement of positive 20. The phase displacements are set up to be dealing with minuses. So if you have a minus and then a 20, you're only worried about the 20 as the phase displacement. So I'll take a stroll to the right. This one has a phase displacement of
40. Negative 40?
negative 40. In other words, it's headed to the left 40 degrees. Phase displacement?
There is none.
There is none. Phase displacement?
Negative 10.
Negative 10. Phase displacement?
Positive 20.
Positive 20. Question about phase displacement stuff?
This isn't like especially about anything, but is that like another abbreviation for sine, SN?
SIN. I just like,
Oh, okay. I get it.
okay, a little messy. Okay, so let's do some graphing now. Okay, for this, if the vertical displacement is 2, what that means is everything is going to have to move
Up to.
up 2. So we're no longer going to use the x-axis as our home base the way we did yesterday. We're going to have to go up 2 squares. Quick recap for purposes of people who weren't here yesterday, strolling to the right into open space. The basic sine graph yesterday had what numbers on the x-axis? 90, 180, 270, 360. Our highest mark was 1, our lowest mark.
Negative
And where did sine's graph start?
1, 0,
At the origin. At the 90 mark,
Up 1.
up,
Touching.
touching,
Down.
down,
Touching.
touching. So we're going to mimic that graph now in this world, but everything just got shoved up 2 squares. So if 2 is our center point, I'm going to draw a dotted thing that's called the axis for this problem. We're no longer worried about the x-axis being our landing point for a lot of dots. We're now worried about this axis for this problem being our landing point. How high is the highest? Three, because it's 1 more than the axis. How low is the lowest? 1, is 1 down from the axis. Is there any reason to change the 90, 180, 270, 360s if we move up? No, those are going to remain the same for this problem. And I'm not going to start here anymore. I'm going to start here. This is our axis. Starting point. At 90, I go up. At 180,
right there.
touching the dotted axis. At 270,
Down 1,
go down to the 1, and we always finish
where we start.
where we started. Something about that? For this one, phase displacement of 20, where did that move us?
20 degrees.
To the
Right.
right. Would there be any reason to change the standard 1 and negative 1 if we're moving right?
No.
No. Leave the 1, leave the negative 1. Our starting line is now 20. So where is our finish line? 380. Because everything just got pushed back 20 degrees. In the middle of that, you could either average these, which will always work every day, or you could just like today, add 20 to every number. It doesn't matter. This will be 200 in the middle, 110 instead of the 90, 290. Sometimes people get freaked out about this. They're like, yesterday we only had 4 numbers, today we have 5. 1, 2, 3, 4, 5 numbers. Yesterday only had 4 numbers. Yesterday had 5 numbers too. Why did yesterday have 5 numbers? Origin was 0. That was a number. We had 5 numbers yesterday. We still have 5 numbers today. That's pretty boring. Then you have to fight off the temptation after establishing a habit yesterday. You don't start here.
Start at 20.
Start at the 20. The phase displacement has established a new starting line for us. And at the next mark,
Up 1,
up,
on there,
touch,
down 1,
go down,
and where we started.
finish where we started. So this one, the up-downness of it, where are we going?
Down.
Down 3. And draw the dotted line called the dotted line is called the axis. Highest high, -2, because we're just up 1. Lowest low, -4, because we're down 1. How does the -40 come into play?
You go left.
I go left. So I'm going to start back here at -40. So I should probably extend my axis back a little bit that way. Finish line? 320. Because it's still 360 later. In the middle, you could either average those numbers or you could subtract 40 for today off of anything. In the middle,
140.
140. To the right of the 140. $230. To the left of the 140 is 50. And then where's our first block going to be?
At the -40.
At the -40 and
Down 3.
down it, lined up on that axis. When we get to the 50 line,
The 15, like,
going
oh,
up, but resist the temptation to go here.
It's -2.
We want to be lined up with the -2. At the 140,
1,
with the touch point, at this,
down 1.
go low, finish where we started. Question about that? You're getting a taste of yesterday too while we're doing this. Does this make sense what we're doing? Cosine's a different shape. So it's all the same numbers, so I'm just not going to write those all up as duplication again. How was cosine different?
Start off 1.
It starts at the top, and then down, or
Or to the
touch,
origin. Or not the origin, the
touch,
axis.
down,
down,
touch,
touch,
up.
up. If you graph them side by side, they like roll parallel to each other. It's the same shape, just a little bit. So if we want to graph this, where does this head us? Down 4, which makes our top point -3, our bottom point -5. Our numbers for this part of the world are the usuals. And then where should I start? Disagree? Disagree. At -3, because we ran out of numbers, and also where? At a height of -3 and
0.
Oh, like on the y-axis?
on the y-axis. We'll start on the y-axis at -3, because cosine starts at the top. I should draw my axis on, I guess, while I'm at this. When I get to this mark, I should be at the axis. This mark is at the bottom. Touch. Always finish where we started. Next one, where are we going?
To the left.
Left 10. So So all these x-axis numbers just changed. Finish line is now
350.
350, halfway, 170,
260.
260,
80.
80, highest high is the 1. And I'll go a little bit up out of the way so I don't run into my numbers, because the numbers have a tendency to get in the way of what you're doing sometimes. Lowest low is -1. Should I start here?
No.
No.
Like foot over a 10. Yeah.
No.
Okay.
Up near the 1, but above 10.
Yes. We'd start here if it were, what would make me go there?
Sine.
Sine would make me go in the middle at the starting line. Cosine always goes to the
Okay.
top of the starting line. So cosine's at the top, 80,
Touching,
touching,
down,
down,
touching,
touching,
and then up
up.
at the 1.
Last one. How's the 2 manifest itself?
Up here.
Up 2. Thought. Top
3.
3. Bottom
1.
1. How does the 20 manifest?
To the right.
The right 20, causing a finish line,
380.
380. In between,
200.
yup,
290.
yup,
And 110.
yup. And then where's our first dot going?
At the 3 on the y-axis.
Disagree?
At the 3 at the 20.
At the 20. We've moved the phase displacement, moved the starting line to the 20, but we do want to start cosine high, yes. 110
At the 2.
is at the 2. 200,
At the 1.
bottom, 290,
At the 2.
touch the axis, and finish
3.
where we started. Tomorrow, there's nothing new, we just put it all together. Okay, so yesterday you had amplitude or period or both, with an occasional flip in the mix as well. Today you have vertical displacement, phase displacement, and I think they do sprinkle in some of yesterday's in a limited way. Tomorrow, you're looking more at, you're looking more at something like that. Okay, so if we do just a quick small preview, which of these numbers is based on today, the vertical displacement
The
number?
2 in front of the
The
plus.
2 is the vertical displacement. Which number is the phase displacement? The 5. Which number is yesterday's amplitude?
3.
The 3. And the 4 doesn't directly tell us anything, but it leads us to the period if we do
Divided by
360 divided by 4. We put that all together in a big monster list, and the graph gets obviously a little more work to figure out what the numbers are. Because today, a lot of the time, we got to use our usuals, the 1 and the -1, the 91, 83, 60, We use those a good bit today. Next lesson, all of that goes totally out the window, and every number is just all over the place.
If you were to like graph that, would you have to do double set of parentheses? Or-
You would, your
Okay.
calculator would force those on you. As soon as you hit sign, it would force this one, and then you would have to close it.
Okay.
Where we're headed, homework on this is 33. So 1 and 2 are just the basic sine and cosine graphs unchanged, just to get those sealed into your memory banks. From 3 to 8, it's combination of vertical displacement and phase displacement. When you do 9 to 12, they're flashing back to yesterday and getting back to amplitude and vertical, but they're not putting them all together. They're keeping it only to 1 or 2 items per problem. So the homework, as always, is twofold. So one thing we want to do is make this list of facts. The other thing you have to do is make a graph. So we want to go both of those per problem. And I guess we could cut that.